Hello ladies and gentlemen, we're going to do 13.1 today, trig and right triangles. So we're skipping ahead a couple of sections and then we will eventually go back and pick up the ones that we left behind. Alright, so the first thing that we're going to do today is we're going to talk about using the Pythagorean theorem to find missing lengths of triangles, and then we're going to go back and review our basic trig functions, sine, cosine, and tangent. And then we're going to use those ratios to find missing pieces of a triangle. Okay? All right, so first things first, let's go back and do a little bit of review on geometry about some specifics about the way things are labeled. So I'm going to call this triangle A, B, C. All right, so A, B, C. Notice that B is a right angle, and so the side opposite the right angle is called the hypotenuse. The side opposite an angle is used or noted with a little letter. So technically this would also be little b, and then this would be little c. So we use lowercase letters to talk about the lengths of a side, and we use capital letters to talk about the angles. All right. My Pythagorean theorem, okay, only works in a right triangle, says that a squared plus b squared, is going to equal c squared. So this doesn't correspond to my diagram. So this says that the length of a leg squared in GTH and the length of the other leg squared is going to be equal to the length of the hypotenuse squared, since I didn't label my triangle well. Okay. The other thing that I'm going to review is your trig ratios. So there are 6 basic trig ratios. We're only going to manage 3. So our trig ratios, okay, so if you'll remember, the sine of an angle, and theta just represents an angle, okay? But we're going to do some big kid math, so we're going to use theta. The sine of an angle is the opposite over the hypotenuse, okay? The cosine of an angle is equal to the adjacent over the hypotenuse, and then the tangent of theta is the opposite over the adjacent. So some people learned a little an acronym, I guess that's the right word, to help remember this, and so you would say SO, CA, TOA, and those are used to help you remember the ratios. All right, so let's do a little example, and let's go back and solve. Here's my little triangle. Okay, that's going to be the right angle. Our trig only works on right triangles for the time being. In future math classes, you learn to do cool things with it, but we're going to solve for h. Okay, so the first, sorry, my bad. I want to find the sine, the cosine, and the tangent of theta, and I always want to leave those in ratio form, okay? But before I can do that, I have to find h. So you always have to find h first, okay? All right, so if I find h, I'm going to use the Pythagorean theorem, which says a squared plus b squared is c squared. So I'm going to use that information, and I'm going to say 5 squared plus 12 squared is going to equal h squared, or h is going to equal the square root of 25 plus 144. Oops, I forgot the 1. That's the square root of 169, which is 13. So the length of my hypotenuse is 13. Okay? So now I'm going to go find, and I'm going to do it up here so you can still see our triangle because I kind of ran out of room. The sine of theta is opposite over the hypotenuse, and now I know my hypotenuse, so it's going to be 12 over 13. The cosine of the angle is the adjacent, and adjacent always means right beside. It's going to be 5 over 13, and the tangent of theta is opposite over the adjacent, and that's going to be 12 over 5. And so those would be my answers for sine, cosine, and tangent. All right, so in theory, you've learned all that before. You learned it in Algebra 1. You used it again in Algebra 2. okay? Or sorry, in geometry. So now we're going to do it again in Algebra 2. So let's do another example. Okay, so this one says evaluate sine, cosine, and tangent of theta. Most of the time, when we're doing these problems, we want to leave our answers in fraction form or radical form, okay? All right, so we're not going to go ahead and get decimals. We're going to leave them as a ratio because that's what they are. They're a ratio. So here's going to be your diagram, lovely little triangle, okay? This is going to be 15, this is 17, there's the theta, and there's y, okay? So before I can find my ratios, I first have to find y. So I'm going to use my Pythagorean theorem, which was a squared plus b squared is c squared. So I'm going to get 15 squared plus y squared is 17 squared. So y squared is going to equal 17 squared minus 15 squared. And I'm not going to do that math in my calculator because I'm going to do it all in one step. Now I'm going to take the square root of both sides. And so I'm going to get the square root of 17 squared minus 15 squared. And I'll just show you how I do that on my calculator because I don't want to waste time doing things that I don't need to. So I'm going to do the square root of 17 squared minus 15 squared, close, go. And the answer is 8. All right. And when I'm doing things that are related to geometry, when I find something, I always add it to my diagram and I circle it. That's just my own particular habit, so I know what's new. Now I can find my angles. So the sine of theta is going to be the opposite over the hypotenuse, which is opposite 15 over 17. The cosine of theta is the adjacent over the hypotenuse, and that's going to be 8 over 17. And the tangent of theta is the opposite over the adjacent, and that's going to be 15 over 8. Okay? So there, we're done. So basic trig is actually fairly straightforward. A couple of reminders from geometry. Okay? All right. We need to remember that the shortest side is always going to be opposite the smallest angle. And we're talking about triangles, of course. And then the largest or longest side, I'll do longest side is going to be opposite the largest angle. Okay, and again, we're still talking about triangles. Okay, so now I need to remind you of some formulas that you should have learned in geometry, and they're called your special right triangle formulas. And I'm actually going to show you a new way to kind of manage them. So the first special right triangle that I'm going to talk about is a 30, 60, 90. Okay, so here's my handy dandy little triangle. All right, this angle is going to be 30, this angle is 60. Also remember a couple of words from geometry. Complementary means 90 degrees, and supplementary, those are long words, mean 180 degrees. Okay? All right. In a 30, 60, 90, it doesn't matter where the 30 and the 60 are. Opposite the 30, because it's the smallest angle, is going to be what I call the short leg. Okay? Opposite the 60 is the long leg, and then always opposite the hypotenuse, or sorry, opposite the right angle is going to be the hypotenuse. Okay? So we learned some formulas, or you should have learned some formulas in geometry. Okay? And that said that the short leg, and I'm sure they didn't actually write the formula like this, but this is how I've always taught it, is going to be the hypotenuse divided by 2. The long leg is going to be equal to the short leg, SL represents the short leg, times radical 3. Okay? That's not S times L, that is the short leg. And then the hypotenuse is going to be equal to 2 times the short leg. Okay? So those are the formulas. We also represent those formulas in a slightly different way as you move up in math. So I'm going to draw the same triangle. Okay? And it creates a ratio that I can use to help me solve. Always opposite the 30 is going to be a 1. Opposite the 60 is a radical 3. And then opposite the 90 is 2. So we actually use that information quite a bit in Trig in your upper division math. So at Flag High, it will be in AMC or pre-calc. All right. My other special right triangle is a 45, 45, 90, which is called an isosceles right triangle. Okay, scoop my paper up a little bit. All right, so here's going to be my right triangle. And right triangles that have legs that are the same length and base angles that are the same is actually kind of glorious because the math is significantly easier. So I'm going to call that a leg and a leg. So the legs are both equal because it's a 45-45 isosceles right triangle. Its handy-dandy little formulas are going to be the hypotenuse is equal to leg, radical 2, and both legs are the same length, so I need less formulas. And then my leg is going to equal the hypotenuse divided by radical 2. All right, so let me scoot my paper over just a little bit. This can be shown in different ways. So I'm going to write leg is equal to my hypotenuse divided by radical 2. We don't like radicals in the bottom, so I multiply by radical 2 over radical 2. So the formula turns out to be h radical 2 over 2. Okay? All right, this is the way I usually start my problem. I remember that it's the hypotenuse divided by radical 2, and then I manipulate the formula as I need to. All right, so let's do an example using our special right triangles. Okay, so the directions are going to say find x, and you don't get to say, here it is. That's not okay. All right, so here's going to be my handy-dandy triangle. Okay, let's go in this direction. There's my 90. Here's x, and I know that this is a 30-degree angle, and I know that the hypotenuse is 8. All right, so if this is a 30-degree angle, that means that this is also 60. So now I have a 30, 60, 90. So remember, opposite the 30 is 1, opposite the 60 is radical 3, and opposite the 90 is 2. So I'm going to use those to set up a proportion. Okay, and I'm going to set up the proportion, and I'm going to use cosine because I want to solve for x, and cosine is the adjacent over the hypotenuse. So in my black pen, I would say that the cosine of 30 degrees is going to equal the adjacent over the hypotenuse, which is going to be x over 8. And then if I use my ratios, the cosine of 30 degrees is going to be still the adjacent over the hypotenuse, and so it's going to be radical 3 over 2. Okay, so that's actually kind of handy. Well, because the two cosines are equal, I'm going to set them equal, and so this is going to give me x is to 8 as radical 3 is to 2. Now I can use my special right triangles to solve. I'm going to cross multiply, so I'm going to get 2 times x is equal to 8 times radical 3. Divide both sides by 2. Then I'm going to get x is equal to 4 radical 3. And that's how I'm going to leave my answer. I'm going to leave it in radical form. Okay? I'm going to show you also how to do this on your calculator. So I'm going to go back to the cosine of 30 is equal to x over 8. If I want to solve for x, I would do cross multiply. So those two guys, x is going to be times cosine of 30. A couple of things you need to be careful with in your calculator. Okay? When I go to my mode button on my calculator, notice right here on the degree line, there's two types of measures of an angle. One is radians, one is degrees. You need to make sure that your calculator is always in degrees, because if it's in radians, it will give you an incorrect answer. In a couple of sections, we'll talk about radians, but for right now, we need to manage our math in degrees. Okay? So if I do this 8 cosine 30 in my calculator, and I would do 8 and then cosine 30, I would get that x is equal to 6.928. Remember, 3 decimal places are always appropriate. So notice that these two answers are equal. Okay, 4 radical 3, if you did that in your calculator, it's going to give you the same thing as 6.928. The key component is how they ask you to find your answers. If anything says exact, that means no decimals, period. If it doesn't have the word exact in the directions, then you could actually use the decimal equivalent for your answer. Okay, so I will be pretty specific when I do a problem whether I want your answers in exact form or if I want it as a decimal. Okay? Alrighty, so that gives you 2 different ways to do the same problem. Okay, let me do another example for us. Okay, this one says solve. I guess you can't see it, sorry. This one says solve the triangle. Anytime you see something that says solve the triangle, that means find all missing pieces. And then all of those answers would, of course, have to be written in the answer column. Okay? And pieces can be sides, pieces can be angles. So you're going to be given this triangle. Okay? And I'm going to have A, I'm going to label it as A, B, and C. So this is little a, little b, little c. You're going to be given that angle A is 71 degrees and little c is 20. And that's all you know. So I need to find little a, I need to find angle B, and I need to find little b. Okay? And I'm going to do the whole problem with trig. I'm not going to use the Pythagorean theorem. So the first thing that I'm going to do is I'm going to find angle B. I know that the sum of the angles in a right triangle, these two are complementary. They have to add up to 90 because 90 plus 90 is 180. So if I subtract the 71 from 90 and get 19, now I know that angle B is 19 degrees. Okay, that was easy. Now I'm going to solve for A. Okay, so now I'm going to solve for this piece, and I'm going to write my 19 on my diagram, and I'm going to circle it so I know that it's something that I found. So if I do A, I know the hypotenuse, and I don't know the opposite, so I'm going to do the sine. So I'm going to say the sine of 71 is A over 20, cross multiply, so I'm going to get A is equal to 20 sine 71. All right, and I'm just going to show you that on my calculator. I know my calculator's in degrees because I just put it in degrees. 71, close go, and I get 18.910 for the length of A, equals 18.910. Okay. When we're solving trig, I usually put the number out front. I wouldn't put this in, and notice that it opens a parentheses and closes on your calculator. All right, so 2 down. All I have left to do is find little b, okay, and I am not going to use the Pythagorean theorem. I like trig better. But now I'm going to switch and use that 19-degree angle at the top. And again, I'm going to try to use things that I haven't found, because if I use A and I made a mistake in A, then I'm going to make a mistake in B. So I try to use original information wherever possible. And I am going to use the 19 because I'm assuming that I can do that math without making a mistake. So I'm going to say that the sine, because it's opposite, the sine of 19 degrees is opposite, that's a little b, over 20. So little b is going to equal 20 sine 19. When I do that math, I get that b is 6.511. Then I'm going to add that kind of to my pile of answers. So I found angle B, side A, and side B. The cool thing about trig is there's often more than one way to do a problem. I could have done tangent, I could have done cosine, so there's lots of different ways to do a problem. All right, so I'm assuming at this point that you can do that math. So let me do, because it is a review of stuff that you've learned now for a couple of years. So I'm going to do another example. It says let theta be an acute angle of a triangle. Okay, find the values of the other 2 trig functions, and I want you to leave your answers leave in radical form. Okay? So you're going to be given that the cosine of theta is equal to 5 over 8. And that's all that you know. And I need to find the other two functions. So I need to find sine and I need to find tangent. Okay? So the first thing that I'm going to do is draw a triangle. Oops, I'm going to go the other way. I'm going to scribble that out, sorry. There's my right angle. I'll explain why that's my default triangle in a couple of sections. So I'm going to let this be theta, okay? And it says the cosine of theta is 5 over 8. Well, the cosine is the adjacent over the hypotenuse, so that means that the adjacent is 5 and the hypotenuse is 8. There's my hypotenuse. Here's the adjacent. So now I need to find this value, and I'm going to call it x. And now I could do the Pythagorean theorem. So 5 squared plus x squared is going to equal 8 squared. X is going to equal the square root of 8 squared minus 5 squared. I skipped a couple of math steps, and so I'm going to get the square root of 39. 39 doesn't reduce, and I'm going to add that to my diagram and circle it so I know I found it. Okay? So now I can find sine. So the sine of theta is going to be equal to radical 39, the opposite over the hypotenuse, and the tangent of theta is opposite radical 39 over the adjacent 5. And there are the other two ratios. So that was pretty easy. All right, let me give you your problems. Alrighty. First problem says evaluate. Excuse me just a sec. Would you close my door for me, please? Thanks. Evaluate the sine, cosine, and tangent of theta. And I want you to leave your answers in fraction form because it's a ratio. So your diagram is going to look like here's theta, here's 8, and a 3. So I want you to find the sine, the cosine, and the tangent of theta. Number 2 is going to say let theta be an, acute angle of a right triangle. Find the values of the other, keep writing the same word twice, other two trig functions, and then leave your answers in radical form. Okay, and you're going to be given for A that the cosine of theta is 5 over 6, and B, you're going to be given that the tangent of theta is 3 over 4. All right, let me show that to you. Okay. All right, one more quick little problem, and then we'll be done. Last problem, number 3, says find the exact keyword here, and it will be a keyword for the rest of the chapter, meaning no decimals, which means you have to use your special right triangle formulas. So I want you to find the exact values of x and y, and then here's your diagram. Okay, there's my handy dandy little triangle. This is 8, this is 60 degrees, this is y, and this is x. So I want you to find x and y, and you do need to use your special triangle formulas. Alrighty, good luck with your math, and I will see you tomorrow.